Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So this is the fifth video of the Arduino project handbook. This is the fifth project of the Arduino project handbook, and it's plant monitor. Okay, so in this project, I'll introduce a new type. That's from Mark Geddes. That is from the author of the book, saying he will, as I will introduce a new type of analog sensor that detects moisture level. You set up a light and sound alarm system to tell you when your plant needs watering. Now this is how it looks like. So this guy right here, this thing you see right here, is actually a sensor. Okay, moisture sensor. So look at the things we'll make use of here. So that sensor will sense, this sensor will sense when we need to water the plant. And when it detects that we need to water the plant, this guy will turn on, the buzzer will turn on, which is give us audible, it will give us sound, and this one will give us light. These two are together, and of course microcontroller, the Arduino, and then the breadboard. Of course we'll make use of jumper wires. So yeah, so this is the name of the moisture sensor, and this is the other component. All right, so this is how it works. This particular sensor, moisture sensor, the way it works is this: the prongs, which is 1 and 2, these prongs, okay, of course prongs of the sensor, and the sensor is what? Moisture sensor. And now what happens is that it detects the moisture level of the surrounding soil by what? Passing current. By what? Passing current through the soil and measuring the resistance. Damp soil conducts electricity easily, okay, so it provides lower resistance, while dry soil conducts poorly and has higher what? Resistance. Now if you look at this thing, I think I need somewhere that has better, well, I think that's what I have. Or let me just come to the simulation here. Now I'm simulating it because I do not have this soil moisture sensor. Okay, so that's how I'm simulating it. So this is the connection here. I will explain the connection and then show you what's going on. Now this, when this is inserted in the soil, the two prongs we have here, now this what happens when electricity, it passes electricity through the soil. Now if these two, of course this will be inside the soil. I think we have a picture like that here. We have them inside the soil. Yes, so you can see they are inside now, inside. So if current easily flows from one to the other, that means the soil is what? The resistance is low, meaning the soil is wet. Wet soil conducts electricity easily. But if the resistance, if the resistance is high, that means current flowing from one to the other. If the resistance is high, it means the soil is what? Dry. This is the idea behind it. So what we'll do is just to make the connection. Now if you look at this, you will see this is VCC, okay, which is the one that sends and the one that powers this particular sensor. So we power this sensor from the microcontroller, the Arduino. Okay, so you see, we use it to power what? The sensor. Okay, and of course when you give it live, which is 5 volts, you also take what? You also connect it to ground. Okay, so that's what we've done here to ground. Look at it. So when I put my mouse pointer here, you can see it highlights all through, so you can see where the wire is going. All right, then this guy sends what? Signal from the sensor to the Arduino. Of course, we connect it to the analog pin. Okay, so this is serving as our input. These two powers this guy, and this one will send signal out of this guy, which is the sensor, to the Arduino. Now these two are just what? Outputs, giving us sound. Okay, and of course you connect the output to ground. Okay, and then of course this guy give us light output also. We'll connect a resistor in between this guy, in between the positive of the LED and the Arduino pin, and then of course connect it to ground. This is a complete connection. All right, so let's go to the program now to do that. So I'm using the IDE provided by Tinkercad. Oh, by the way, I'm making use of Tinkercad. This is Tinkercad environment. All right, so to write our code now, what we do is we start by doing what we normally do. Let me say plant monitor. Can we see the screen? Program. Let me make this bigger. Okay, bigger. Yeah, better. Okay, so of course, variables. Now we've said that we are making use of the sensor. Okay, so sensor, and we connected that one to A0. Of course, that should be integer, data type int. Then for the LED, we connected down to what? Pin 13. And then for the buzzer, we connected it to what? Pin 12. Okay, now I think we can stop here, but if we need another thing, we are going to add it. If we need another thing, and I think we do, but let me just go step by step like this for now. Now in our setup, void setup. So now to set up this thing, all we just need to do is the usual pin mode, but there's something that was added in the Arduino project handbook, and I'll show you what that is. So pin mode output, which is the LED output, and then pin mode buzzer is also what? Output. I need a T here. Output. Yeah. Now, in the Arduino project handbook, if you check the program there, you see they added this particular thing, which is a serial.begin, and they added 9600. Now, this is to establish communication between the Arduino and the serial monitor. Look, this is the serial monitor, meaning the readings we are going to get from the sensor, they should be displayed here. That is one thing. Another thing is that we want to display text on this serial monitor. We can display anything we want on this serial monitor, text we want on the serial monitor, and we can also display the values we get from the sensor here. But for now, let's just display something. Okay, so serial.begin, that means we want to display this 960. Just tell us the bit rate. That's the communication between the rates of communication, bit rate communication between the microcontroller and the serial monitor, and usually it's 9600. That's kind of the number used most of the time. So let's print something. This is serial.print. Okay, so let me say plant monitor. Okay, so I think we're done here. So now we'll go to the void setup, loop. So void loop. Now the first thing to do is to read what? Read the value from the sensor. To read value from the sensor. Now let me see this. Okay, that has been declared a 0. So what we'll do first is to what? Say read moisture sensor level. And how do we read the sensor level? We do what? Digital, sorry, this analog pin. So we say analog what? Analog read. There is a sensor. Now this value, you read it and put it somewhere. Let me say sensor value. Okay, or let's just call it read. So that means you have to put that one here. It's read. Good. Now, after reading that value, the next thing to do is to check. I think I should comment this thing. Read sensor value. So that means what's coming out from the sensor. And I think people can even print itself. After you realize, let me even print it. Print serial. But this is not in the serial.print. It's not in the Arduino project handbook, this part, but let's just add it. So you print, the LM means new line. Okay, you print equals to new line. Let me even add it here, new line. Okay, so read. This read means we are printing this value, what this thing means. That's what we are printing, read. If I put this double quotes, it means I'm printing exactly what you have here. I'm printing it as a string, collection of characters, string. But if I remove, if like this one now, there's no double quote, it means the, like, hello, like this one, there's no double quote, it means the, what does read represent, what value is coming into read, that is the value that will be displayed here. Okay, so we just print that, and then we say what, let us, the next thing we'll do, let me say read and print and display. Okay, read and display. Since we've gotten this part now, all right, so okay, so by doing this now, we've been able to read, this will read the value, okay, the soil moisture value, voltage value rather, but in essence, soil moisture, we read that value and save it here. Now this will be what's printed. But guys, if we do this each time this thing with a value, it will get printed. But there is something we can actually do so that it will only print a value if there is a new value. Okay, so in order to do that, it means that we will first of all have to compare, let me say CM, oh boy, let me say COP, let's compare. Okay, so this is what we will do. If read is not equal to what? Compare. Okay, so what do I mean by this? What do I mean by this? Let me use C compare. Now, this value, we are the ones to declare it here. Let's put it there. Int compare. And then let's start with 0. Okay, let's just start with 0. So now when you read value into this guy, into read, this guy is 0, right? So what will happen is this, is what is being read, is it the same thing as 0? If not, which is read not equal to compare, if that's true, then we'll now say compare, they will now put read, meaning what the value inside read, will now put it inside compare, and then we'll do what? Now we can say now we can say serial.print. So what we are going to print now should be what? Compare. Okay, now I hope you understand what just happened. That is, this read is actually, we are saving the value of the sensor inside this guy temporarily. Okay, and then we'll now check what is being saved inside the sensor. Is it the same thing as what is in compare? For a start, what is in compare is what is 0 for a start. So now we see that, oh, it's not 0, we have a value and that value is not 0. So what is here is not the same as what we've read. So what we'll now do is to do what? Carry what we have read from the sensor, carry it and do what? Put it inside compare, and then we'll now print it, meaning we are printing the value of the sensor. So if this, when this loop goes, let me close the loop, the if condition. Okay, so when this thing happens, meaning once the sensor reads again, read this value here, it will do what? Compare again. Remember, let's say for example, if it reads, let's say 50, okay, the value is 50, and now the first time here is 50, here is 0, abi 0 for the first time. Then we'll now move that 50 into this guy and display the 50. Now the next time when this one, maybe this one reads 50 again, then compare. This guy now is now 50. This one is also 50. So which means it will not print. But if it reads again, and here's now, let's say 70, and here comes 70, here is 50, then since it's not the same thing, what will happen? We'll move the 70 to here, making here now 70, and here we now display. This thing just ensures that we only print if there's a new value given by the sensor. Alright. So what we'll now do is this. We'll say if compare is greater than what? Let's say 900. I can change this value, but this value I saw inside the Arduino project handbook, but I can change this value to anything. Let me use 800. Okay, remember the value goes from what? It goes from 0 to what? 1, 1, 0, 2, 3. Yeah. Okay, now we've done that before, saying that how we got that value is what? 2 raised to the power what? 10. 2 raised to the power 10, because the input there is what? 10 bits. 2 raised to the power 10 will give you what? 1, 0, 2, 4. I think I've said this in a lot of videos. Then counting from 0 to 1, 0, 2, 3 will give you how many digits? Counting 0 including 0, that will give you how many digits? 1, 0, 2, 4. So 0, 2, 3. Okay, so 800 out of that is quite high. If the reading is high, it means what? If the reading is high, it means that the soil is what? Dry. If how do we explain this? Okay, I think I will need something. Okay, let me just say it now. If the reading is high, that means the value I get it from the soil sense of that value coming in. If that value is high, it means the soil is dry. Why? Because when the soil is dry, the resistance is very what? High. Okay, and once the resistance is high, the current drops, flow of current drops, and once that happens, the voltage increases, because this thing works with a voltage divider circuit. And once the current reduces, the voltage increases. So the value being read from this guy, it's high, indicating that it's dry. So we treat it as it's dry. Because if the value coming in is low, then we say, okay, the soil is wet, meaning there is current, high current, flow of electricity, there's high current, and there will be low voltage, so low reading for wet soil. Okay, so if this value is higher than 800, that's quite high, then we can now say well, let me turn on digital write LED high, and then it's write buzzer high. Okay, I'll close this, and then I'll say else dg to write led low, and then digital write buzzer low. Okay, close this, and then of course we delay for some seconds. Let's 100 milliseconds. That's okay. So this is it. So let's try it and see to connect. Okay, let me just connect quickly. Okay, I think I can add something. When this guy turn on, meaning it's high, turn on the alarm. Do we need to let it? You can just turn it off, delay a bit, and then turn it off. Let me bring these guys here. Okay, so if it's high, that the soil is dry, it will turn on, then turn off. Then check again. If it's dry, turn on, turn off, that kind of thing. Okay. So let's go. Simulate. Okay, so let's start the simulation. All right. Okay, so that's what's happening. Let's see the values in the serial monitor. Where? Click this serial. Look at the serial monitor here. Yeah, so look at the values. All right. So you can see the values changing. Now, no new values coming in until we move this guy. Going higher now. Going higher now. All right. That's it. Nice. Okay, that's that for this video, and then see you in the next one. Thanks for watching, and bye for now.